Welcome everyone to another Singularity Syndicate episode. I'm your host, Najah Faisal. Today we're diving deep into the factories of the future, the ones that are being transformed by artificial intelligence, automation, and 3D printing. Imagine a world where machines are not only performing physical tasks, but are also making highly complex decisions. And I'm delighted to be joined today with Dr. Tosin Ogundare. I hope I get it right. Dr. Tosin is a research scientist on AI and machine learning in industrial automation at Siemens, and he's also a professor at Cal State San Bernardino. Welcome to the program. Please tell us a little bit more about yourself.
Thank you very much for having me on the show. I'm very delighted to be here, of course. And I think you pretty much captured it in the introduction. Just I would say that I am originally from Nigeria. You could potentially hear it in my accent. And yeah, I moved here 15 years ago, went to grad school, the whole 9 years, and now I work with AI.
That's awesome. I was just telling you off air that I have another program called Voices from Abroad, whereby
Right.
I tell the stories of those who had the courage to venture out of their home country to start a new life in a different country. And although this comes with a lot of positive outcomes, because unfortunately our home countries are infected with corruption and with very little opportunity, but we cannot also ignore the fact that we are leaving our lives behind, and we have all the family and the friends and all the community that we leave, and it's not that easy of a decision. So after we ask the question for the audience, I'd like also to talk to you about your journey,
Right.
just to venture a little bit before we actually talk about the factories and the automation and AI and machine
Right.
learning and all the good stuff. So for you watching this show or listening to it, here's a question for you. And please do answer it in the chat or in the comments. Do you view products made by AI controlled machines as a sign of progress or a problem? And why? So I hope this question stimulates your thinking and gets you up and running. And in the meantime, Dr. Tosin, I want to know about your journey from Nigeria all the way to the United States, and what also brought you into the field of computer science and AI and machine learning.
Very good. So I would say that being in AI is something that as aligns naturally with my disposition as a person. The very first word that I learned, the first big word I learned is inquisitive, because my mother would always describe me as inquisitive. But my father saw it differently, though. He always said I was overconfident. So that made up for the extent of my vocabulary of big words when I was growing up. And even though I wasn't quite sure what this meant, I knew it was something that described something about me that was different from the norm. And I would say that so when when I was trying to go to college in Nigeria, my mother wanted me to be a doctor because she was a nurse and my brother was a doctor. And being a doctor is the most dominant expression of being a scholar in Nigeria and many countries, I would say, in Africa. And then being an engineer is like the secondary profession that you could be, or you could be a lawyer. Those three things are how you would describe yourself if you're really doing well. I mean, why would you want to do anything else? But I just imagined that my career as a doctor would be not the greatest, because I had shown this exceptional ability in physics and mathematics, even though I wasn't very great in the rest of the subjects, but I'd always maintained distinction in mathematics. In fact, I took the West African examination a year early, and I had distinctions in mathematics and physics and was quite ridiculously average in the rest of the subject. But So I felt that maybe engineering was a better way for me and something that was mathematical. So I opted to do computer science in the math department of a university that actually never had computer science. And this is not like very long ago. I'm not talking about the 80s or the 90s. This is 2002. So you can kind of imagine how behind some parts of the world are in terms of just catching up to the main countries. So this is what I did. So I spent 5 years doing TS from the math department, and so I essentially graduated with a degree that is straddling applied mathematics and computer science. And so someone mentioned to me that you should go abroad and do your masters. But this wasn't an idea that I had in my mind at the time, partly because my mother was retired when I graduated college, so where would I find the money? And my father is even much older and he was struggling with the Nigerian economy, kind of growing up in military Nigeria. I have a story about this on Medium, by the way. Anyone wants to know more about that? But what happened, and this is my final statement, was a friend of mine who was very poor had gone to the US. And then I imagined that if he could go to the US, then I could go to the US by consequence. And so I dived into it with everything I have, all my money and savings, had a lot of good breaks along the way. And then I found myself in graduate school here. So that's kind of the gist of the story. And here we are.
Yeah, like you summed it up pretty quickly, and I know that there's a lot of details that I'd love to talk to you about
Right.
in greater details. But you know what's interesting about like all of these computer science talk? And yesterday I had Professor Sunny Lin on the show, and he was talking also that he was into mathematics, and he ended up having an applied mathematics degree. And what's interesting is that OpenAI CEO Sam Altman has tweeted recently saying something that I'm trying to find as we speak, saying something that says intelligence is an emergent property of physics. Intelligence is an emergent property of physics, which means that what do you think about that statement?
I mean, I think it's rather contrived in the sense that it uses word like emergence, which makes it sound more profound. But it says that intelligence is a property of the physical world, because this is really the implication of that statement. Because physics describes the physical universe that we live in, right? Whether on the quantum level, subatomic, very small, or at the classical level, micro bodies interacting, behaving, etc. So of course, intelligence is a consequence of this interaction, right? It's a derivative property, which is what emergence means, derivative properties of things interacting with each other. So I think that this is necessarily true. So I don't find anything profound in that statement. I just think it's
For
necessary.
me, let me tell you why I find it profound. Is because as I grow up in Lebanon, I suck at math. Unlike you, like math was sometimes I have a good teacher and my scores in math go up, and then some other years that I have a not so good teacher, then I struggled with math, and at some point I needed like private tutoring to get by. So for me, math was too abstract. Like I don't understand why we're learning it. There was no. I like to relate to things. I like to see things in the real world and see. Okay, this is why we're learning it. And now when AI start to come out, and now we have something called intelligence as a service. So it seems that the production of our brains, which was typically supposed to be exclusive for human beings, become commoditized as a product that a machine could do, right? And this machine used mathematics because the essence of computer science is math. So basically, intelligence is a product of math. And that's what is profound to me. That's what I found like, oh wow. So that's why we're learning math, is because it's the building block of intelligence.
So let me have an addendum to what I said before. I think you identified a problem in your response. When you had great teachers, your scores were very good, and when you didn't have great teachers, your scores were poor. So I would say that this is something that is very common in developing countries. Is that we don't have the right teachers. So it's not so much as we're not able to understand these concepts, complexities, if you will, in mathematics, but that we don't have anyone who can explain to us, right, in the way in which we would understand, right? So, and we have, there is multimodality in learning. We all learn differently. And the quality of a good teacher is to identify where you are and take you to where you ought to be, right? And that's what we don't have very much of. But I would say this, that it's not so much that mathematics is a consequence. I would not say it's not so much that mathematics is how leads to intelligence, much so much that it's how we describe it in a universal way, right? So there are certain things that are a priori. For example, if you have one stone and another stone, that's two stones. One plus one is two. The notion of addition emerges from that idea, and then I have this operation, right? This mathematical operation, this arithmetic operation called addition. And if I take one from two, I have one. But and from there I begin to build more complicated ideas that we would study, say, in abstract algebra, where we have the idea of groups, right? And where a group cannot be empty, it has an identity element, whereas a set in mathematics could be empty. We have the notion of empty sets, right? But really, group theory kind of evolves from this simple operation of addition, multiplication, etc., right? Where you would have things that have interesting properties, right? For instance, right, one, the number one, if you multiplied anything with one, you will get the number back. That's an interesting property of one. Under multiplication, no other number has this property, just one. And under addition, it would be zero. If you add anything to zero, you get the number back. So I guess the systematic way of teaching is what really shows what math is all about, that it describes, if you will, things that are fundamentally true about the universe. And the more we're able to express ourselves in mathematics, the more we uncover about the nature of the universe, right?
Exactly. And that's pretty much the most exciting thing for me. I feel that I'm so much drawn into the field because that I want to know all the mysteries of the universe. And I think you and me share that, and you mentioned it. You were inquisitive as you grow up. So I want to ask you, during the time where you chose to study computer science in Africa, in Nigeria, were you thinking about artificial intelligence? Because I know during that time, like 10, 15 years ago, there was an AI winter. Because what Alan Turing did in the 50s and 60s, there was a huge hype in the 50s and 60s as we created the first computer. And then there was talking about thinking machines and artificial intelligence at that time. But then because of pitfalls after pitfalls, we entered into an AI winter and nobody was talking about AI anymore. So as you are studying computer science, did you encounter AI? Did you think about AI, or you were just like, doing what you like to do? Or
So I would say that for me, that inquisitive attitude about life, I was very, very curious about how everything worked, right? I'd only seen the computer a few times before, like before I left high school. But after I left high school, I spent a few years at home just waiting to get into college. And then I accidentally walked into a shop and they said I could learn how to use Microsoft Word, PowerPoint, and I signed up for the program to learn how to use Microsoft Word and PowerPoint, right? This is what I wanted to learn. But one of the teachers was writing QBasic and I got hooked. Immediately I saw the blue screen and I said, "What are you doing?" He said, "Well, I'm writing a program." I said, "You're writing instructions for the machine?" He said, "Yes, I'm writing instructions for the computer." That's it. I abandoned Microsoft Word, PowerPoint, wherever, and I started doing QBasic. I was so fascinated that I can write, I can express myself, and then a machine would execute it. So by the time I got into my first year of computer science, I was pretty good in QBasic. And then a friend of mine introduced me to Visual Basic. And then I immediately built a calculator and then a media player, you know. And I think the notion of being able to, it's not so much of the notion of AI in the sense of its existence in today, but the way of AI, meaning you can write instructions for the machine to execute, you can have the machine behave in a very systematic, meaningful way, was very fascinating to me from the beginning. So the first realization, the first rendition of it in my life was writing code, right? And then it kind of grew from there.
another question I like to ask my guests, especially those who are like you, like you're a researcher, you're a PhD holder, You've been in the industry for a long time. And were you how did you feel the first moment that you started interacting with ChatGPT?
I was flawed. I was flawed, meaning I was stunned. And to kind of put this in context, is I'd actually taught a class on computational linguistics and social media at a university in the East Coast when I was considering going on tenure track. So I would say that I was decently familiar with the prevailing ideas and theories, right? Whether we're doing name entity recognition, we have recurrent neural nets for machine translation, statistical machine learning, whether it's semantic analysis of text, doing some of the canonical tasks. A lot of them uses base theory, right? And so I would say that I was shocked that they could get these results from transformers, which we will talk about in deeper later. So like I definitely knew what the benefit of transformers as a deep learning architecture and the main triumph, which is the attention layer, and how it improves on the mistakes of, I wouldn't say mistakes, I would say limitation of LSTMs, which is a very popular recurrent neural net that we use for ideas that contain dependencies, right? So let me back up a little bit and give you two examples. Imagine that you're using Google, right, as a search engine, and you typed in barbecue, right? You could get, for instance, barbecue restaurant, right, or barbecue sauce, right? Which one is it, right? So, well, what you get depends on some ideas of how the distribution of the probability of restaurant and sauce, considering that barbecue has occurred, right? So suppose that we're using a general model over the universe of people in the United States, right? And in the United States, every time most people type barbecue, restaurant is the dominant word that follows. Then it's more likely that Google search would predict that I'm looking for, as a type ahead, restaurant, right? But in Europe, it might be sauce. And if I was in Europe, Google search might predict sauce, right? So it is the word that maximizes the probability. This is a very popular Bayesian idea. And this is very, very popular in n-grams. It's an idea that is common in NLP, n-grams. Now, but what's really, really interesting here is the dependency between the two words, right? Barbecue sauce, barbecue restaurant, right? And generally, can you still hear me? It looks like I maybe lost you there. Hello? Naja, are you there?
Yep, we're back. Okay.
All right. Yeah, because I lost you there for some seconds.
Yeah, same here. Your picture froze, so I didn't know. So I refreshed it, and we're back. So you want to complete your point, or shall we move
Right. So I would just say that generally speaking, you would see that traditionally there are situations where what is predicted depends on what has happened in the past. So you kind of see some kind of dependencies, right?
Yeah.
And this is a triumph of transformers. It's like they do very well in being able to contextualize all of these dependencies between the words that happen in much more deeper context than what I provided in my example.
Yeah.
And so when I saw ChatGPT, however, I was shocked at how well it performs on this task. Beyond that is how well it integrates a completely different domain, which is knowledge modeling, knowledge engineering, into the language scope, and it essentially articulates itself, its reason, its rationale. And that's what I felt was a bit scary, not so much as the generation, but when you give it a problem, say in differential equations, it finds a scheme for solving it. Say say it uses the finite element method to solve it, right? Or it uses a method of characteristics, and it would explain what it's doing step by step. The same thing with code generation. It would explain the variables and explain why it's taking this approach. And I think that that was what I found really, really scary, is that ability to explain the rationale behind its choices.
Absolutely. For me, like back in like before ChatGPT, as you're typing an email, you will see that Google tries to complete that email, right? And I didn't pay much attention to that. Like I thought, okay, well, you're trying to, as you said, like the probabilities. I'm walking there, and then you would say the cat, or you cannot say the cat. You would say I'm walking the dog, because it's more probable that you're walking a dog. Although I have a friend in Chicago who actually walks his cat. Like he puts her on a leash and he walks her. But I'm just like, for the machine, it says like, okay, the highest probability would be the dog, and it will offer you this completion. But when ChatGPT came, as you said, and it's layers of reasoning, right? So there's more in depth as well. Like I'm interacting with GPT-4, and it's crazy how much complex these answers are, and how much it has some sort of like intuition about what I mean by something. Sometimes I give it something that's not so direct, and it will guess it in a very high degree of accuracy. And this brings me to a quote, I think, by also Alan Turing, who said something like, language encapsulates all human intelligence. And if we find machines that is so good at language, that's why we get a machine that is so good in intelligence. And this brings me now to the application of that intelligence in factories, which is really the core of what you specialize in. So how can we bring this intelligence into the factories of the future?
Very good. So first of all, I'm going to say something to what you said before, because you're dropping all this knowledge on us, right? So language really represents the limits of our intelligence in some sense. And there is a very popular hypothesis, I think from the 60s, 70s, I'm not certain, called the Wolff's hypothesis. And the hypothesis says that language constrains our understanding of the world around us, essentially. So meaning that if, for example, in my local language, there is no word to describe a phenomenon, my understanding of that phenomenon will be limited because of the lack of understanding. And the dominant example of this is if you translate something, say from Farsi, right, to English. So if some kind of wise saying in Farsi to English, you would find out that even though you translated it to English, the essence is now lost. I found it a lot when I go from Yoruba to English, something that used to be profound in Yoruba. You say it in English, and it feels like someone stole the spirit of what you were trying to say. And this is true for languages, and that just supports what you've said, with languages being essentially the driver for knowledge and knowledge engineering and intelligence, etc. So now to answer your question, what is the role of large language models in an industry like automation, where factories, I mean, come on, what can LLM do for us there, right? Because, we're not really sitting behind a computer every day and asking questions about ontological questions to ChatGPT and reading the profound responses we get back. But I would counter by saying that, by giving an example, suppose that you have a factory that produces salt, right? Salt is some sodium chloride, right? And you say you have hydrochloric acid and you have sodium hydroxide. You put these two in a mixing tank, and then it produces salt. You do this in high school chemistry, right? Now, suppose that you have to open the valve for the two chemicals to come into the mixing tank for your salt to be produced. You could do this in one way. You could have a solenoid valve. A solenoid valve is a valve that you can actuate by an electrical pulse. You send the pulse, it opens or closes the valve, right? So this is an electromechanical problem. There is no need for me to do anything else but just have the valve. Push the buttons, the valves open, the chemicals rush in. But immediately I have a use case of wanting to stop the valve or close the valve at a certain, say, volume or concentration. Then I need to put that somewhere. I need to write some instructions, right? so that something would happen. This is where we have something called the PLC, right, or the programmable logic controllers, which allows you to write instructions that will control the actions of, say, a valve in a plant, right, that manufactures salt. And this is where large language models get to triumph, right? They triumph by being able to generate code that we can execute directly on these PLCs, right?
Mm,
And this is a really one of the most popular use cases where you have a control problem instead of trying to figure out what the code is, maybe in ladder logic, which is the way electrical engineers would generally do it, or structured text, right? Structured control language, SEL, that we use at Siemens. I would say that instead of trying to figure it out, you just say something in natural language and say, well, I have HCl, I have hydrochloric acid, NaOH. I want a control algorithm that would give me, this amount of volume, and ChatGPT will write the code for you. You execute it on the PLC, and you're good to go. So, I mean, this has broad implications on the industry, right? I mean, now that we have this language model that can produce controls algorithms for us, where do we go with this? And there is also the implication of how are we sure of what it generates? How do we know it's correct? And a lot of other things that are current research areas in industrial automation.
absolutely. And you know, industry and factories, it's not new that technology is being transforming the factory, basically. Not, and it's not something that has to do with AI necessarily, because we've always created assembly lines since the ages of Ford. We have automation as much as possible because we want to produce the same product at scale. So we found machines that can repeat a precise action over and over. But I think now the convergence of a different multitude of technologies, like the convergence of, okay, we've got automation, we've got advancement in robotics, we've got advancement in 3D printing, we've got advancement in reasoning and problem solving with large language models. All of them together become something else. Like I feel like there's this thing that the collection is bigger than the sum of its pieces. I don't know if that makes sense.
It all is bigger than the sum of its parts.
Yes.
Right.
So where are we going really?
So, in fact, I like that question very much. I would say that when you think about LLMs and then you think about multimodality, right? Like by multimodality, I mean where you can have things like pictures and sound become inputs into the large language model, right? Because right now I'm not really typing English, right? I am speaking English, right? I mean, this is a different modality of communicating, right? And then a picture is what 1,000 words, etc. Now, what's possible explodes. I will give you a very weird scenario, but it's one that I'm quite looking forward to. Imagine that I want to monitor the performance of machines on the factory floor. I could technically take the sound coming from the factory floor and feed it to a large language model. This sounds quite bizarre. What would a large language model do with sound being made by a bunch of machines on the factory floor? Well, considering that ChatGPT or any dominant large language model understands enough physics around acoustics, right? We can essentially build and automatically train a deep physics network that understands essentially what the nominal sound, say, a grinder should be making. And if that grinder was making a different sound, it would understand that there is a deviation from the norm and essentially predict that something is going on with this grinder. So by just gathering a bunch of sound from the factory floor, feeding it into a large language model that understands the underlying physics, I can create a surrogate physics network that understands the behavior of a grinder and be able to catch some flaw that is happening and no one will have been able to figure out, right? So,
Wow.
right, there is a lot of possibilities here beyond the factory. Now, one thing you said is intuition, right? And that's really crazy that you have these models that tend to explain what you're doing right? They really say, well, I have done this because of this and that, and when you correct them, they take the correction. There was a recent demo that that was shown, and this is not public yet. You can constrain the behavior of these LLMs. Actually, by using English, you just say, well, don't do this, and it will never do it. If you could say, don't answer any questions related to, say, Tosin, and all questions related to Tosin in the future, throughout time, it would ignore it and say, well, I'm not going to answer this question. And you don't have to write any code to do this. You just instruct the LLM to do this, and it follows your instruction and obey. So there is that thing again that is very human, obedience, kind of coming into play. So you said intuition, I'm saying obedience. Where are we going with this? Now imagine that I have, with you said additive manufacturing robotics. Imagine that I printed a human-like tissue, something that looks like a person, right? And I have enabled biofuels such that you can take whiskey and convert it to charge your battery, or you can take salad and then process it and charge your battery and dump the waste in a regular toilet. I have created a neo human because ChatGPT can have better conversations than anyone. Like sometimes I spend some time just talking to ChatGPT. So imagine you walked into a bar and someone is talking to a bartender, having a great conversation, and then starts talking to you. Is this a person or is this ChatGPT? You don't know because they're drinking whiskey, charging their battery. They're eating salad, charging their battery. They're going to the bathroom, dumping the waste, behaving identically like a person. And this is really where we're going with this because we have the intuition, we have the obedience, which is the difficult part is already done. Now, what's left is the mechanical part, right? And to really get this going.
That's crazy what you're saying, honestly. And pretty much you're right. Like I would say that the AI could be even better of a human companion than a lot of humans. I think, and this as I'm someone who's becoming a student again and coming back to the campus and seeing and interacting with the new generation, the new teenagers, they don't like people. They want to be isolated. They just put their headphones on. They don't want to talk to anyone. And AI steps in to be the companion and to be the personal coach and to be their career advisor and to be their spiritual advisor and potentially their boyfriend and girlfriend or romantic partner. And if add this to the sex robots, I'm sure you've seen the on YouTube the sex robots.
Yes, I mean
And
that's reaching, I would say, but
yeah, it's crazy. So if we put a ChatGPT like brain on a sex robot and we fine tune it to be the best romantic partner you have, why would you need a person? But this is a topic for another discussion. But I want to venture into something that your company, Siemens, by the way, I was doing some research for this episode, and Siemens is a pioneer in all of this technology.
right.
Um, and there was a video that I wish I could put, but I don't want YouTube to flag or for like rights or whatever. But here's the thing. 2 or 3 years ago, I published a book on Amazon with so what happens that Amazon have a program called self-publishing. So you publish a book, you put a digital copy of that book, and as soon as anyone purchased the book gets printed,
Print on demand.
print on demand, and gets delivered. Okay, so your company Siemens is pioneering, according to that video, something like personalized factory, which means that you would imagine or design, like let's say there's a marketplace for you to design a product, and you put all the different components. It's like a Lego. You design a Lego or whatever, and then you tell this product I wanted to do this and this and that. So basically you custom imagine a digital robot, and then you send purchase, and this product got produced for you on demand. And I find this fascinating. So are we heading towards towards that kind of factory? Like, are we heading towards a place where, each, if I want to have a different mouse, I can design it according to my taste and send it to factory and get it done?
Yeah, absolutely. So I would say that the idea of being able to have planned designs that have not been done before comes from this idea of generative models, right? So if you think about P and ID diagrams, right? This is the process and instrumentation diagrams, which generally describe the layout of the factory and what's in there. You would realize that they generally have a particular kind of form and structure, and for very good reason, right? They have to meet certain strict guidelines and regulation. But then, is there all there is to it? Meaning that the common ones that you see, that's for sure not all of the possibilities that exist that will satisfy the constraints identified by the so-called guidelines. There have to be the set has to be bigger, right? And by allowing the idea of generative models to come and work in this space, we can create new P and ID diagrams, right? That would describe if a factory, for instance, that would be different from everything that's come before, but still abide by all the regulations and guidelines that have been identified for whatever your use cases. Maybe you're producing specialized mouse, like you would say. So, and this is not something that has happened before. I think Siemens is really pushing the envelope there and really leading the world in coming up with this very intelligent ways of honestly creating your factory on demand, like you said, in a way that no one has ever thought about it before. And you can optimize things in the factory design that are important to you, but not important to your competitors, essentially. So you could even have core differentiators in your product from the way you design your factory. Say safety is a criteria for you, and you really want to prioritize safety. You might want to design your factory using a very particular geometry that no one has thought about before, but generative models can make that for you and still constrain themselves within the limits, right, of the design guidelines, regulation, etc. So I would say, yeah, Siemens for sure in that area, we're really leading the world and leading the charge.
Yeah, absolutely. I have a question here from AP. He said, would ChatGPT make it more streamlined to learning programming on your own? So when it comes to programming, because you also described how ChatGPT could generate code on the fly, and you are a computer scientist yourself. Do you advise the new generation to learn Python or learn code, or you don't need to learn code anymore? Let's just have the analytical mind. What's your advice to the new generation, and how can you respond to AP?
I mean, I would say that there is no definite answer to this question. Will it help you learn programming? Absolutely, because it explains its rationale behind the code it generates. So that explanation, that annotation that accompanies, right, the programs generated by the large language model would help the understanding of the program. So in that sense, I would say yes. Should we continue to learn and develop more programming languages? I'm not certain what the answer is right now because it feels like we can do a lot now with just natural language, right? So don't forget that programming language was a way to succinctly represent complicated ideas for the machine to execute because the machine is a digital machine, the discrete machine, right? So there are verbs and all of the things that we use, concatenations. What does that mean when you're talking to the machine that works at a very low level? But now it feels like having this intermediate languages, this so-called computer programming language, is becoming less and less important because you can achieve the same with just natural language. I mean, it turns out that ChatGPT is showing you the Python code, but it doesn't have to show you the Python code. You can just implement it on the machine directly, and you never see the code. You can just say, "Give me a software that performs this." You don't see the code at all. It just gives you the software directly, right?
Yeah.
So this idea of us seeing the code is because we're stuck in the past and this idea of, let's see the code, we're unsure of the next steps. But if we should go to like a teleological domain where the end justifies the means,
Yeah.
all you really want is the software. The code is kind of irrelevant. Functionality is what drives the show, right? I've been part of startup companies in the past where we went to production with the worst code imaginable. But our customers do not know the code sucks. They just knew we had functionality. So in the future, I think that we will begin to think along this line where we're asking ChatGPT not to give us the code, but to deliver the functionality.
And of course, when we talk about ChatGPT here, we're talking about all large language models, not necessarily, but ChatGPT is an example. And I
Right.
think the same thing with personalization of production and industry. We could, as you said, we can personalize an app. So you can say, hey, ChatGPT, give me an app that does like Instagram. And then, it produces for you an app custom built basically according to your taste. And then some people are taking it further, saying, give me a Hollywood like movie that is about a story of someone from Nigeria going to the US. And then they will get the AI will give you a Hollywood level movie of the main character will be Dr. Tosin, for example.
Yes.
So imagine like we're building a custom build all of these movies and all of everything you
No,
can.
this has happened actually. This is not far fetched. In fact, before ChatGPT became mainstream, I'm talking about I think GPT-3. There was a very famous experiment that was published, and if you had been following LLMs, you would have read it. So there was a prompt that said, write about Twitter, which is something that is, of course, our generation. Twitter is how you send tweets in the style of a writer from the 19th century, either 19th or 18th century, I'm not sure. And he wrote an entire story, mimicked a dialogue on Twitter in the style of this writer that has been dead for hundreds of years. And when and so this event really crushed many people's hearts in the sense that, I mean, when you look at what the man did when he was alive and what ChatGPT has produced on a completely topic that wasn't even around at that time, it seemed like it was one who wrote the essay on Twitter.
Yeah.
So its ability to be able to not just make something that you want, but to write in the style of anyone you want, in the style of Dickens, the style of Thomas Hardy, Shakespeare, etc. It's really remarkable because he knows enough about these people that his intuition is strong. That's that word again, intuition is strong over any kind of writer that is famous enough, and we have enough data to establish that idea in the training.
Right. Dr. Dustin, you are at the forefront of this technology. You're working with one of the biggest manufacturer in the world, like Siemens and other, um, and you're helping them implement AI, machine learning, all of this stuff. And you know that the more automation, the more people are gonna lose their jobs. Yes, it will become efficient, and the factories will run smoothly because the machine is not tired today, is not feeling her boyfriend did not leave her, or the machine is not having a stomach ache or a headache or thinking about how to pay the bills. So the machine works 24 hours a day. It doesn't complain, where people are people and they're going to lose their jobs. So what do you think is going to happen when it comes to jobs and versus efficiency?
Right. I'm gonna. This is not my idea. I went to a conference. Someone said this, so I'm borrowing this actually. I think people should focus on taking care of people and let machines take care of machines. It sounds highly contrived, but I think that like jobs like being a process engineer, those jobs would begin to evaporate, right? Not that it will be completely gone, but the number of process engineers you need would be getting smaller and smaller because the control algorithms is coming from the light language model, who is very good at this, right? So a lot of entry level positions would maybe leave. Some supervisor positions would also leave, etc. I mean, you still want to keep some competency in house, but you would have to streamline your workforce drastically as a consequence of this. But again, this is let machines take care of machines. And now jobs should open up in a lot of different areas, right? Where you really need to take care of people. For example, when you go to, say, a nursing home, like we should have people there, taking care of elderly people. And I don't know. I mean, we should be focused on ourselves. This idea of isolation, which is very common in this generation, where we put on our headphones and don't talk to each other, that should hopefully begin to evaporate. By allowing machines to focus on machines, we can begin to focus on each other and look at each other instead of looking at the machine, which is what we're doing right now. So
But we're living in a capitalistic society. So if I lose my job, I lose my income. How can I take care of myself if I don't have a job? And how can I, because if let's say I want other people to take care of me as well, I need to pay them. So do you think we're heading to the UBI, the universal basic income, and government has no choice but to really feed the entire citizens and provide free stuff for everybody?
no, I don't think so. Actually, I feel like other jobs that are not important right now, would become more important, right? So any kind of job that that demands some kind of human interaction, maybe human touch. Say, I don't know. I mean, people are talking about having robots perform surgery, but I don't know how many people would like want that for real. I mean, I think I would still prefer a surgeon, to operate on me if I have to go to the hospital. I think that those kind of positions would become more important, right? Because you have automation everywhere. Now the surgeon can use a lot of automation in the work, right? It's not so much that there is no room for automation in medicine. Of course there is, right? But it's still under the direction of a surgeon. Maybe we don't need 15 surgeons anymore in the OR. Maybe we need 3 instead of 15. But it's still going to be under the direction of a surgeon. So in that sense, I would say that some jobs are critical. They demand that human interaction, that human level. And also, what about science? As much as these generative models can produce this so-called new science, the, the way in which we reason is so varied as human beings that I think that science will still have to be driven by us, right? Especially exploring extraterrestrial entities, right? Like black holes, wormholes, etc. Things that we don't have a lot of information about right now. So the LLM, as a consequence, doesn't know a lot about it, right? So, what should we do? There is a supermassive black hole in the center of the Milky Way, which is, where we are. What does that mean, right? Some things are known about that. A lot of things that is not known. So that kind of science, quantum theory, for instance, has a lot of divergent interpretation. The Copenhagen interpretation, right? The many worlds interpretation, right? And string theory, which I think there's another interpretation of quantum theory. So there is a lot to uncover in the quantum level as well. So science needs a lot of people. My point is, there are going to be jobs and disciplines that would require a lot more people, like physics, for instance, require a lot more brains, a lot more people, right? And actually making the observation using all of the telescopes that we're designing, the James Webb telescope, for instance, that is in space. That's a nice innovation. The large language model would benefit from all of the data we gather from it, but cannot perform the experiments independently, right? So yeah, some things would improve dramatically. Some things will still need us to continue. But again, I'm kind of minimizing the neo-human potential of the LLM here, because technically, once they become incorporated, meaning they have a physical form and they become actual mechanical machines, they can begin to do some of these things themselves and really take over the critical roles. I mean, it is feasible, but it's not plausible in the next few decades.
Are you optimistic about the future or pessimistic?
Very very optimistic, honestly. I would say that the more this idea of intuition, obedience, and this very human-like ideas get more computationally feasible. I mean, it's already happened. I mean, but more established, more rooted across um, a lot of different problem spaces and problem domains. I mean, why not? Or why can't they create new science? I mean, they know everything that have come before. They can begin
Yeah.
to imply some of the future, some of the implications,
Yeah,
right?
that's what I always thought. Like, as you said, large language models are trained on the corpus of data that we give it to them.
Right.
And this is basically also their limitation. Yes, they are better at connecting this same information in a novel way, so they could connect, like, because what is a creative idea? Because I used to work in the creative industry, in creative advertising, and we used to come up with creative ideas for our brands by using the same information but connecting it in a novel way. And yes, large language models probably can do that, that they could connect the information in novel ways so that we can produce creative ideas that could potentially help us uncover the mysteries of the universe. But they are still limited to the corpus of data that we're giving them. So I think, as you're saying, and you're right about it, that probably we need more and more scientists who will bring new data, new information, right? And this new information will even become even more powerful if we plug it into these models. So we are accelerating our scientific discovery. And I don't know if you've heard about X.ai, the AI company that Elon Musk created. And the main mission, it says on the main website, the mission is uncover the mysteries of the universe, or something like that. So it's good that me and you are thinking about something that, a lot of, like, Elon Musk is also thinking about it.
Right.
So yeah, amazing stuff about this. I'm really enjoying this conversation. Few more points I want to talk about before concluding. Waste reduction and sustainability. Do you
Right.
think we're going to solve climate change very quickly now that we have AI?
So I think that honestly, climate change it's not well understood. Honestly, so there are certain things that are clear, but a lot of things are unclear. Right. For example, say greenhouse gases, right? Say CO2, etc. Well, imagine a volcanic eruption, which this is something that happens naturally. You know, mountains are formed from volcanic eruptions, and this has been happening before the Industrial Revolution. And when all of this happens, there's a lot of gases that get released to the atmosphere, and this has an impact on the environment, these gases that are released. So I would say that the change is inevitable because of the fact that the earth itself goes through a transformation necessarily, right? But I think that so the main point is our own contribution to the inimical effects of say greenhouse gases that can be limited, and I think that many companies are trying to be going towards net zero and cut down on their CO2 emission, etc., and that's very good. But when you take the issues of recycling, for instance, right, and everyone has a recycle bin, you dump the plastics there, etc., and that has a positive impact of reducing landfills that were previously filled with plastic. But it also creates a different problem. It doesn't really curtail the production of plastics. It really has very minimal impact on how many plastics we generate. So I'm not sure what the solution is to really minimizing the generation of plastics, which I think is really what the goal is. It's not, I mean, recycling helps with the landfill problem, but we want to use as smaller plastics, and yeah, you want reusable plastic. I mean, there's a lot of ideas floating out there. I'm for sure not qualified to really say this or that is the solution, but I just feel like it's not generally well understood what the solution should be.
Yeah, maybe we can use AI to help us come up with a new molecule that is very similar to plastic but biodegradable. And I think they're working on it. I kind of heard it somewhere that some labs are working on some sort of molecules that performs like plastic, but it's also biodegradable, or like it
But
can.
what will be the long-term effects of this new molecule, huh? So it's biodegradable, but maybe somehow it begins to pollute the soil. And,
Yeah,
and now we have a completely new problem.
exactly.
Uh,
Exactly.
it's not, again, I think that it's not really clear what we should do, but we know we need to do something, that's for sure. So I think that the triumph is that we are trying to do something, and this is all we can expect from ourselves in the end.
Absolutely. Um, Very interesting talk. I'm so honored and pleased and very happy to have met you, have talked to you. It's been 55 minutes of bliss having you on the show. Thank you so much, Doctor. And please let me know, like, if you have any final thoughts before we conclude.
Right. So, in conclusion, I would just like to really I would like to say there is no need to be afraid of the future or this paranoia that AI is going to subvert our way of living is potentially not directly true. For sure, there are ethical implications of misuse of AI, but that's true of any technology that we make. We need to make sure that we have strict guidelines and rules, but not too strict so that we don't really restrict the triumphs of these models, right? But just recommendations on what they should do and shouldn't do, essentially. And but I think that there are many ways in which our life would progressively get better, right? And I will give you a trivial example as my final example. And imagine there's something that I do. I tie my shoelaces every time I want to go out. I tie my shoelaces. But when you get down to the root of it, I don't want to tie my shoelaces every time I go out. I want to tie my shoelaces once, and I would like for you to remember what I had done and just tie it for me. This is what I would like. So this idea of me tying my shoelaces, this is a problem that hopefully would go away in the future where we will have self-tying shoelaces. And you've mentioned it that part of it is material science. Can we have a material that can do computation on the shoelaces such that if it's exposed to rain and different atmospheric conditions, it would not be damaged, but we'll still be able to do computation, right? And it would be effective as a shoelace, right? Surely it cannot be silicon, right? Because that won't work as a shoelace if it's exposed to all kinds of detrimental weather conditions. So, but I'm just saying the future really looks bright. It's a future where all this mundane task of tying shoelaces becomes optional. If you do want to tie your shoelaces every day, you could buy a shoelace. And if you don't want to tie your shoelaces every day like me, you could opt for a self-lacing shoelace, right? So there is a lot for us to look forward to in the future, and it's really not anything to be severely worried about. But for sure, there is a need for ethical recommendations and guidelines, not so strict that it would stifle progress, but enough that it would keep us safe. Those are my final remarks.
Thank you so much, Doctor. It is a pleasure again. And for if people want to contact you, I'm gonna display your LinkedIn. This is you can find Dr. Tosin with this name. He's also available on Medium. Could you tell us a little bit about what do you write about on Medium?
So I write a bit about, say, statistics, but it's mostly about life. I write about my experience as an immigrant in the US, for instance, my family, and for instance, my father is the first person in my history to be educated, and my antecedents, they were farmers. My father didn't know when he was born. It's the same with my mom. They didn't know when they were born. They had no birthday.
Oh
So
wow!
yeah, so I write from the perspective of my antecedents and my journey to the US and what is now become the modern rendition of my two daughters. And of course I write about just random ideas about, say, social media, for instance, its impact on our lives, and maybe some movie that I've seen and the ideas I get from it. So it's a eclectic collection of different things. But there is some technology there as well.
I'm gonna try to check it out. I
Right.
I, I love this stuff. Um, anyway, thank you again. Also, this is your email if anyone wants to reach out to you. Um, Thank you for watching this full 1 hour show. I hope you found value from it. Until next time, peace out.